7.2 Rational Exponents. We're going to focus on how to convert from rational exponential form to radical form and vice versa. The main property we're going to use is this property right here. If you looked at the 7.1 video, you'll notice that I had said something about that the index divides into the denominator or into the exponent. That's what this property says. If it's in this case radical form, the index divides into the exponent, which means the index becomes the denominator of the exponent. It's a fractional denominator. And so if you have an expression, in this case the base a raised to a fractional exponent, to convert it to radical form you just take the denominator and that becomes the index of the radical. Now you can also go take the exponents on the base and pull it outside of the whole radical, and that's okay also. Sometimes you'll need to do that. Key thing is the index equals the denominator. So here we go. Let's do a few of these and see what happens. We're going to convert first. So when we have 3 to the 1/2 power, what that means is we're going to keep the 3 as it is. We're going to convert it to radical form. Now the denominator is a 2, and that becomes the index, and the number on top, numerator, stays the exponent on the base. The base is 3. The base is the number of the exponent. And that's the same thing. We don't have to write the 2. So that's the same thing as the square root of 3, in case you're wondering. That's all it is. But the key thing is, if you see a square root, that's the same as being raised to the 1/2 power. Because, once again, if you don't see a number on the outside of the radical, it's always assumed to be a 2, because that's a square root. Anytime you hear the word square, you're thinking of the number 2. Let's do B part, 16 to 1/2 power. So let's rewrite that with the 16 on the inside. The 2, which is the denominator, becomes the index, the 1 stays. That's basically the same thing as saying what's the square root of 16, and your answer in this case would be 4. Let's do 64 to the 1/3 power. Now on this one, what we're going to do is we're going to write the 64 down, and then we're going to convert that. But notice the 3 is the denominator this time, so we put 3 on the outside, put the 1 on the inside. So this is the same as the cube root of 64, which if you type in your calculator or just think about it, it's going to be 4. Because 4 times 4 is 16, 16 times 4 is 64. Now let's write this in radical form, 32y to the 5th to the 1/5 power. So I'm going to write down 32y to the 5th. Since the numerator is a 1, I'm not going to worry about the 1 on as the exponent of the radicand, but the denominator is a 5, so I'm going to write that on the outside. So this is now the 5th through to 32y to the 5th. Now let's do this to simplify this. The 5th through 32, if you type that in, or if you think about it, the answer is 2. 5 goes into 5 one time, and it leaves y to the 1st, or just y. And so we're done with that. Let's do a couple more. And just for the sake of what we're doing, let's just assume that the variables all represent positive real numbers or non-negative numbers. Let's just go ahead and assume that. So when I see this one, negative 4x to the 1/2 power, don't be misled into thinking that the 1/2 is also on the negative 4, because it's not. It's only attached to the x. So the negative 4 stays as it is. And the x goes underneath the square root. The 2 is the denominator, which means it's the index. I'm not going to write it because it's already assumed. I'm not going to worry about the 1 because anything raised to 1 power is just itself. So we're done. Negative 4 times square root of x. Let's do 9 to the 3/2 power. Now, when I do this one, I'm going to write it out like this. The 9 goes, and then I can put the 2 there, which I'm going to for now, and the 3 goes on the inside. Now here's something special about this one that you need to be concerned about. We can rewrite this without the 2 and the exponent as the index, because it's understood to be there when we don't write it. And then the 9, but we can take that 3, and using this version of the property, we can take the exponent inside and move it completely outside, which is what I'm going to do. The reason why I'm doing that is because I know what the square root of 9 is. The square root of 9 is 3. And then 3 to the third is 27. So that's the reason why you may want to pull out the exponent on the outside, so you can do what's inside, make that much easier to do. And now let's do the next one. We got negative 27. 3 goes on the outside, and 4 goes on the inside. But once again, if you want to, and I do want to, I'm going to take that 4 and move it outside. The reason why I am is because I know what the cube root of negative 27 is. So I'm going to pull it all the way out underneath the radical, out from underneath the radical. Because the cube root of negative 27 is negative 3. And then negative 3 to the fourth is the same thing as negative 3 times itself 4 times, and you get 81. So just be aware. Now let's go ahead and do F part. X plus 1 raised to 3/8 power. I'm going to keep the x plus 1 as it is under the radical sign. The 8 is the denominator, which becomes the index. The 3 stays on the inside. I can pull it outside. There's no reason to, because I can't simplify any further until I'm done with that one. For G part, notice that the 3 is the index, because that's the denominator. The 2 will be the exponent. So I'm going to write it like this. And I'm going to keep the 3x inside of parentheses. And once again, that 3 that's the denominator goes on the outside and of the radical, and the 2 stays on the 3x. You can write it like that, or you can write it like this. Either way is perfectly fine and acceptable. And now let's just do a couple where we go the other direction. In this case, you're given radical form. Let's convert to exponential form. Once again, we're going to assume that all exponents represent, or all variables represent positive real numbers. So what's going on here is I'm going to write down x to the third as it is, but 7 is the index, but it's also the denominator. That's all you have to remember. Index equals denominator. Now it doesn't matter if the exponent's on the outside or on the inside. You can write it however you want. If you want to, you can rewrite this problem. The 6th root of 2x all raised to the 5th power as the 6th root of 2x, parentheses, raised to the 5th power on the inside, which may be the easier way to think of it. It doesn't matter. Same thing. You do what you need to do. So I'm going to write down 2x with parentheses. I'm going to keep the 5 as it is. The index is 6. The index becomes the denominator. And so that's the same as 2x raised to the 6th power.